Okay, this is our fourth and final example. And what I want to point out here is that we don't have a product of two functions like we normally see when we are doing U substitution. We actually have a sum. Okay, so the very first thing I'm going to do is split this into two separate integrals. So this is really the antiderivative from 0 to pi of sine x dx plus the antiderivative from 0 to pi of the cosine of 2x dx. Okay? And the reason I'm splitting these is because the inside, the x and the 2x between the two trigs are not the same. So we're going to have to approach these somewhat differently. Okay? So let's go ahead and figure out the answer for this first one. Then we'll come back and take a look at the second half. And then we'll figure out how to get a final answer out of the entire expression. Okay? So, taking a look right here, the antiderivative of sine is negative cosine. Okay, if you think about that list that we made, the sine, cosine, negative cosine, we need to go up one, so really going to the bottom of the list. We're going to evaluate that from 0 to pi. So that's going to be the negative cosine of pi minus the negative cosine of 0. So that double negative, we can actually turn that into a plus sign. Okay? So I really have negative cosine of pi plus the cosine of 0. So we need to know, well, what's the cosine of pi? What's the cosine of 0? Okay? So if you picture a cosine graph to assist you with this, cosine graph starts at 1, comes down, goes down again, comes back up, and up again. Okay, there's 2 pi. So pi is right in the middle. And the amplitude is 1, so this is positive 1, this is negative 1. So the cosine of pi is negative 1, so we've got negative 1 here, which is really just positive 1, plus the cosine of 0 is right here. That's y equals 1. So if I do 1 plus 1, I get 2. So the answer from the first part, the answer to this, is 2. All right? We're going to come back and use that number a little bit later. So now the question is, well, why is this a substitution problem? There's substitution involved because of this right here. This 2x is contained inside of the cosine. The cosine is not just a regular cosine x, it's a cosine of 2x. So I've got to use substitution to get the proper answer out of this. So I'm going to say u is equal to the 2x from the inside. Okay, think of it like there's parentheses right there. So then du is 2 dx. There's no coefficient out in front, so the only way to make this work is if I divide the 2 to the other side, and if I say a half of du is equal to 1 dx. Okay? So that means this integral can be rewritten with a 1/2 cosine of u and a du. So the 1/2 du is taking the place of the dx. I'm just splitting them so that I have the du at the end, the 1/2 out in front. The 2x is replaced by a u. All right. So now I want to go ahead and find the antiderivative of this. So the antiderivative of cosine is positive sine. So this is 1/2 positive sine of u, or 1/2 positive sine of u was 2x. And now I would want to evaluate that from 0 to pi. Okay, my original bounds, 0 and pi. So I chose not to do new bounds here. All right. So I'm going to have 1/2 times the sine of 2 times pi, 2 pi, minus 1/2 times the sine 2 times 0 is 0. All right. So I need to know what is the sine of 2 pi and what is the sine of 0. But if you think about coterminal angles, 0 and 2 pi are the same angle. Okay, so whatever the value is, I'm doing the value minus itself. This is going to come out to 0. All right, but just for a reference, a sine graph starts at 0, goes up, down, up, ends at 2 pi. So there's the 2 pi, the y value is 0. Here's the 0, the y value is 0. So this is really just 0 minus 0 equals 0. All right. So now the question is, what's the final answer? The original problem, we had the addition of the two different integrals. So we're really just going to find the sum of the two values. So the final answer is going to be 2 plus 0, which is just 2. All right. So final answer for the entire problem is 2. And again, that 2 is coming from the answer from the first one plus the answer from the second one. Okay? And there's your fourth and final example.